Good evening. Thank you very much for joining. We'll start in 2 minutes, inshallah. Okay. Does anyone has have any question about anything? Any question about anything? So, yes, Adham, do you want to say something?
I was just gonna say no. I mean, I don't have any questions.
Okay. Okay. So basically, today is the last lecture in the syllabus, inshallah. Uh, uh, Today is the last lecture, inshallah, and we will start the review sessions probably on Saturday. We'll have a review session. I still didn't send you. Uh, I still didn't send you the midterm topics. However, I will do this tomorrow, inshallah, at the evening. Yeah. I want to remind you that you have to submit whatever you have done in assignment 4 today by midnight. And I am not accepting any further delays in that matter. So you have to submit what you have achieved. Uh, then I have posted for you all the assignment that you have till the end of the semester. I am going to post them on Blackboard. Uh, I'm going to post them on Blackboard with the deadline. And you have assignment 5. which is moderate in complexity. It has to do with heaps, with vectors and stuff like this. And then you will have uh, small assignments, which is assignment 6 and 7. And there's assignment 8 that will be given for you as a bonus assignment. Still, it is a short assignment. I want to remind you that time is so short to start finishing up your project. I will give you during the spring break a session about Qt, inshallah. And I have also sent for you mock-up exams, 2 exams. Uh, and uh, and I believe you have to solve them. And I will still send you some more questions for the upcoming exam. So that's it from my side. Any further question you have?
Doctor, when's the project due?
I will tell you about this on Saturday. Everything, the schedule and everything for all the assignments and for the project as well. But basically, Yassine, all the project is uh, should be due around 13 or 14th of May. Around this range. And for the assignments, I will not postpone any assignment anymore. We still have 3 assignments, and you still have a bonus assignment as well. Yeah. Okay. Any further questions?
يا دكتور assignments 5 و 6 و 7 و 8 دول بونص ولا ما؟
في حاجة اسمها assignment 5 و 6 و 7 بونص.
انا فهمتها، انا ريدت فكرتهم بونص بس عشان كده.
لا يعني هي مش
يعني هو في بونص assignment غيرهم، تمام.
لا 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 assignment 5 و 6 و 7 obligatory assignments, and only assignment 8 is a bonus. Yeah.
تمام.
Okay. And remember one important rule, that if you don't submit the assignment, then I will consider it as 0. I will not pick it. I will not pick up the best. يعني assuming that we have 7 assignments, and I decided to give you the grade on to choose the 6 best assignments. So what I will do, if you don't submit assignment 7, then I will consider it a 0. But if you have 10 out of 100 in assignment 7, and you have the rest, you have 80, 90 or whatever, then I will drop the lowest grade. So basically I will drop the lowest grade. But if you opt to not to do any assignment from 1 to 7, I will consider it as a 0. Of course, assignment 8 is a bonus, and it's a very easy assignment, by the way. Yeah. And why did I do so? It's to give you some time to do the project. And I warn you very much that the project is not a piece of cake. It's not something that you will do in 2-3 days. So better to start now. And based on previous experience, some people were literally crying before the submission of the project, because they started extremely late. So I just warn you as a friend and as a big brother that you have to exert as much as possible effort in the project. Literally, some people were literally crying, yeah, including males and females. Okay, so I really warn you about this step, and I really warn you about another thing is that uh, is that there's a cutover date for the assignment in order for the assistant to correct them. So some people were also literally crying, begging the assistant to correct their assignment because they submitted them late. And I have to do the grades. I have to submit the grades to the department. So I cannot accept any delay anymore. So please exert as much as possible. I have been throughout the semester extremely flexible. But now, if you don't submit the assignment, the disaster is on you. So, uh, so you have to submit assignment for today, and then maybe you can later improve on it. I don't mind that you are improving on the assignment. Uh, However, and then in the spring break, you have to do assignment 5, and there remains 2 short assignments for the upcoming remaining 2 weeks. After the spring break, 2, 3 weeks, you have to do 2 short assignments. And those short assignments literally take 1 or 2 days of 2 days of continuous work for assignment 6 and 7. But assignment 5 is not really very easy. So don't depend that it will take 1 or 2 days. Assignment 5 has some sort of heaps and few stuff that you have to take care of. Okay. Any further questions? Okay. So today we will speak about hashing. And for speaking about hashing, actually, I will explain some common common sense concept in real life, and then we will go uh, into the technical definition of hashing. So, basically, if you have a set of lockers, if you have a set of lockers, so this locker is for Muhammad, this locker is for Yasin, this locker is for Ahmed, this locker is for Freddy, this locker is for Zarif, etc., etc. So, if you have the key for a locker, and definitely you know that this key is for locker number 1. So you simply go to locker number 1 and open locker number 1 and get whatever thing that exists in locker number 1. This is common sense. If you don't have the key, so you go for all the lockers, assuming that they are open, and check, is this my stuff? No, it's not my stuff. Is this my stuff? No, it's not my stuff. Is this my stuff? No, it's not my stuff. Is this my stuff? Yes, it is my stuff. Then you go and pick your stuff. So the basic idea here that if you know the key, you will access your stuff immediately in one step. However, if you don't know the key, you will go for each and every locker searching for your stuff. So if we start translating this into computer science terminology, then we can say that it will take you one step if you have the key to access certain piece of information. It will take you one step to do so. However, if you don't have the key, it will take you n steps to do so. Let's translate this into some data structure concepts. So if you have an array that contains 6 elements, of course, and then you want to access the sixth element. So what will you basically do? You will make a loop going from the first element, the second element, the third element, the fourth element, the fifth element, and the sixth element. So each element you will ask yourself, uh, uh, is it the data I am looking for? No, 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 yes. So basically, how many steps you are taking? You're taking n. And what is the time complexity to search in an array? It is order of n. So it's order of n unless it is the first element, which is a very rare possibility. So at all times, roughly, when you search in the array, you will take order of n. Uh, what if you have a way to know where is your data located? So you have some way, you have a key, you have an equation, and you're giving it an element, and it will tell you where this element exists inside the array. So it will take basically order of one. It will take one step. Is it all the time? No, it can't be all the time. And we will know why it can't be all the time. However, we will increase the chances that we will have one step to access the element I am looking for. And this is the idea of hashing. So what's basically hashing? Hashing contains two things. The first thing is a hash table. The first thing is a hash table. And basically a hash table, what is it? It's an array, normal array. Nothing so strange in this. It's basically a normal array. And this normal array has some elements at some location. So for example, element number 11 is at location 1, element number 12 at location 2, element number 13 at location 3, element number 14 at location 4, element number 15 at location 5. No element at location number 0. So it's the hash table is basically an array. And then it has hashing as a concept has a hash function. And what basically a hash function? A hash function basically is an equation. So of course you are experts in calculus and in algebra and stuff like this. So basically a hash function is a function. It's an equation at the end of the day. So basically it is function of x, x mod 10 or x mod whatever. And it can be function of x. It can be 2x plus 1 mod 10. So basically, this is what's so-called a hash function. And what is the purpose of the hash function? What is the purpose of the hash function? Basically, the hash function, you give it the element that you want to know the location for it, and basically it will tell you where it exists in the hash table. Where does it exist in the array? So basically, if you give it 11, I want to search for 11. So hash of 11 equal 11 mod 10. So what does it tell you? It tell you basically that I will find the element 11 at location 1, which is this location. Then if you give it 12, so hash of 12 equal 12 mod 10. So the element, which is 12, will exist at location number 12. So this is basically the idea of the hashing. The idea of the hashing is, first, you have a hash table. Second, you have a hash function. If you want to insert an element into a hash table, you use a hash function. If you want to delete an element from the hash table, you use a hash function. If you want to search for an element into a hash table, so basically you use a hash function. What will the hash function do? The hash function will locate you where this element exists. So this is the utopia situation. And for people that doesn't know what's meant by utopia, then this means that ده هو العالم المثالي. ده العالم الأبيض. But we know that this word is not so perfect here. So in utopia, you will have a hash table that will be large enough to hold whatsoever elements that you want to search for, and you have a hash function that will search in one step. But this is not going to happen. Why this is not going to happen? Because the hash table is limited in size. The hash table is limited in size. And because you will have what's so-called collision. And this lecture, the most part of it is how to handle collision. So basically, what's a collision? A collision is that if this list contains an element which is 25, and you want to insert 25 into a hash table. So ideally, hash of 25 is equal to a hash function, which is x, which is 25, and mod 10. So ideally, you should be inserting element 25 at location 5. 25 mod 10, 25 mod 10 is 25 divided by 10, which is 2, and the remainder is 5. So if you want to insert 25, you should insert it at element number 5. But element number 5 is not free because it contains 25. So basically, this is collision. Basically, this is collision. And how to handle this collision? There are various techniques to handle collision, to insert elements that when you apply the hash function, they will go to a place where it is allocated, where it's allocated. So, and similarly for searching, if you want to search for 25, ideally searching for 25, you should go at location number 5. But location number 5, after applying, of course, the hash function. But location number 5 actually contains 15. So where to go? Where to find 25? Also, this is the topic that we will be studying in further details, in a moment, in a moment. 1 second, please. So, as I said, what's collision? Collision is basically looking for collision basically when you apply a hash function and it goes to a place and you want to insert an element at place where it's allocated. So where to insert this element? If you want to search for an element, you apply a hash function and you find that you don't find the element you are looking for. So where to look for this element also. So this is the basic idea of collision. Any questions so far? Everything is fine? It's easy? Any questions? Okay. So what do we use hash functions? Why do we use hashing? Uh, uh, in 110, it will come in midterm 2, it will come in the exam. I doubt that you will use hashing in your project. But anyways, in real life, hashing is used yes, Kenzie, we will know the answer for your question. So, in real life, what are the usage of hashing? The usage of hashing, it is used for compression algorithms. And what are compression algorithms? Compression algorithms, those are one of the most famous algorithms in life. And if you are using Dropbox, of course, if Dropbox will save the file or the picture that you are saving it, as it is without any compression. Compression means in Arabic ضغط. So what is the purpose of compression? The purpose of compression that you will be reducing the size of the picture, the size of the file, etc., and later on you will retrieve it in whatever original shape it has. So basically, you will be reducing the space for a file, for a video, for everything. Of course, in Dropbox, it uses compression. Of course, Google is using so much compression. Of course, iPhone or Samsung, when they are saving your pictures and videos, they are doing so much compression to have less space to save your pictures and videos. Okay, so they are using a data structure which is hashing as part of the algorithm for doing compression. So it's also hashing is using in cryptography. What's cryptography? It's tashfir. So when you want to encrypt passwords, when you want to encrypt sensitive data, etc., you use hash tables. You use hash tables as well as well as well compression as well hash tables is used as well in compilers like C++ compilers. So for example, when you're using CN and Cout and stuff like this, so usually those keywords are put in the hash table for knowing whether they exist in C++ language or not. And what is the main purpose of hash tables? The main purpose of hash tables will be indicated in the next slide. So basically, the main importance of hash table that if you want to search for an element, on the average case, it is order of 1. If you want to insert an element, it's an order of 1. If you want to delete an element, it's an order of 1. In the worst case, of course, it's an order of n for search, insert, and delete. And how this is better? This is, of course, better than conventional and classic searching for the element. Why it's better? Because classic searching for the elements and doing looping, it is in the average case order of n. So I am doing some enhancement for searching linearly. Linearly means like this or that, vertical or horizontal, about certain element into a hash table. So hash tables or hashing in general is better than searching into the array. So how do we do hashing? How do we do hashing? We do hashing as follows. So basically, I have a list of elements, a list of keys that I want to insert into a hash table. So I have list of elements that I want to insert into a hash table. So I apply a hash function. And this hash function can be as follows. Function of x equal x. Function of k, which is function of k, is equal to 2x plus 3. Anything. Function, it's usually function of k or x, it doesn't matter. Equal, sorry, 2k plus 3. Function of k equal 8k plus 4 whatsoever. It's a linear function at the end of the day, and it has to be x, not x square, not x to the power of 3. This is commonly used. So it's a best practice to use x plus something, yeah. Okay, and I will tell you what is the good hash function. So then this is function of k equal 2x plus 3. And then we make it mod the size of the hash table or the size of the array. And this is usually is called U. So this is the hash function, and we make it mod the remainder size of the hash table. And what's U? U is the location that you will insert or search the element for. So why the mod? Why the mod? The mod is basically used in order to have a circular searching. What does it mean? I'm speaking Chinese. Circular, if you use the function mod the size of the hash table, so assuming that you have 4 elements, so so you will search this element, that element, that element, and then you will start from the beginning. So this is why we use the mod function. The mod function lets you finish, assuming that you start from the middle, let you finish from the middle, going to the list of the function, and then the list of the table, and then start from the beginning. Okay, so this is the use of the mod. Let's apply this. I want to insert those keys inside a hash table. So this is U. So I apply the hash function. The hash function is basically the key, which is 1 and then mod 20. So I should insert key number 1 in element number 1 into the array. So if this is the array, so if this is the array, so at element number 1, I will insert 1. If I want to insert 2, in element number 2, I will insert, in position number 2, I will insert 2. If I want to insert 42, so in element number 2, I will insert 42. But now, this is what's so-called collision. So element number 2 is located at location 2, and element number 42 will be also located at position 2. So this is called collision. How to handle collision, this is what we will learn together. Let's continue together. For mod 20, so key number 4 will be located at the fourth element of the array at location 4. So is it free? Yes, it's free. 12 will be located at location 12 in the array. 14 will be located at 14. 17 will be located at 17. They are all free. 13 will be located at 13, and 37 will be located at position 17, which is also a collision. So we have a collision at location 2, and we have a collision at location 17 inside the array. So Ikram, you want to say something?
Yes, doctor. I want to ask you, like, why do we choose functions that's gonna cause collisions?
Yeah,
Why?
that's a great question, Ikram. Okay, there is no function on Earth that will cause no collision. Okay, so a function that will cause no collision exists in utopia. Okay, so collision is not going is going to happen anyway, but your skill is to choose a function that will cause less collision. Okay, to choose a function, and this is possibly the the topic of the next slide. You should choose a function that it's not too complex. You choose a function that will not cluster the element. cluster يعني تجمع elements في حتة معينة من الارray وتسيب الباقي فاضي. This is called clustering. It will cause less collision, and also it will have no waste in memory. No waste in memory. So it will have what's so called a less load factor. A less load factor. A less load factor. Anyways, so coming back to you, Ikram, there is no function that will cause no collision at all. And what, let's think together. In order to avoid collision, what possibly we can do? So any ideas? And of course, not the people who attended yesterday. Yeah. Any ideas how to avoid collision? So Ikram, let's think together. How to handle collision, not how to avoid collision. How to handle collision.
Let's say we should like take into consideration the number of elements in the array, because for example, when the function.
But we don't know what are the elements that should be inserted or searched for. So if you know ahead the element, so you will not cause any collision. But the issue is that we don't know what are the elements because they might be user defined. So, Yasin, do you have any idea how to avoid how to handle collision?
I'm thinking.
Yeah, Tamer, do you have any idea? Abdul Atif, since you are a great mathematician, so do you have any idea how to handle collision?
We can directly say the location or
We cannot.
the
We cannot. Because if we know where to save the location, then we have prior knowledge about the element that we are going to be inserted. And this is the same of what Ikram was saying. Yeah.
then we can turn each location into a pointer to a linked list.
Yeah, that's great. This is really a good, this is actually the next slide. So any ideas more how to handle collision? Okay, let's see how to handle collision. So, how to handle collision? There are two broad techniques. One is called separate chaining. One that is called separate chaining, and the other one is called open addressing. So separate chaining means that you create a chain outside the original hash table. Open addressing, this means that you insert the element that cause collision inside the hash table. So separate chaining, you will go out of the hash table. Open addressing, you will save the element inside the hash table, inside the hash table. So there are basically 3 techniques for handling collision. So for handling collision using open addressing. The first one is linear probing. And what does it mean, probing? You know that if you want to search for petrol, for gas, for example, so you insert a sensor, a probe, something, and you see, is it a sign that there's a gas at certain place or not? And it is very similar. It's very similar if you لا قدر الله you're doing منظار. So basically, if you're doing منظار, something to check what's happening in your stomach لا قدر الله, yeah. So they will put whatsoever inside your mouth, a wire or something, and there's a lead at the end of this wire, and it will go to your stomach, and then it will check, do you have قرحة لا قدر الله or not? So this is probing. So you probe, is there a free element, a free location, الشقة فاضية or الشقة has some people inside it. So if the block is free, you insert. If it's not free, so after probing, so you will handle collision. So open addressing means that you handle collision from within the hash table itself. Open addressing, it means open addressing means that you handle collision from within the hash table. Separate chaining means you handle collision within outside the hash table. Open addressing, 3 techniques. Linear probing. Linear means something like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. Quadratic means something to the power of 2. Something to the power of 2. Double hashing means that you will do hashing 2 times. You will do hashing 2 times. And you will do 2 hash functions. Let's see how it will work. Yes?
Can you repeat this last part?
Yeah, I will repeat every one. I will have a separate slide for it. So don't worry, I will explain it again and again. Yeah. Okay? So let's see separate chaining. So the first one that we are going to explain in details is separate chaining. It is basically separate chaining. So as Yasin was saying, separate chaining is as follows. Separate chaining, this is the hash table. This is the hash table. How many elements exist in this hash table? It exists 6 elements, and it's usually begins from 7 elements, and usually it begins from 0 to 6. So what is the hash function? the hash function is basically key. It's basically function or hash of k, hash of key is equal to k itself. And to locate the element, and in order for you to search inside any element inside the hash table, so you say mod m. And what's m? It is basically the number of buckets, the number of locations that exist into the hash table. How many locations do we exist in the exist in this hash table? It's basically 7. So basically, you equal the hash function, which is k mod m. In other words, you equal the key mod 7. And what's u? U is actually the location that you will insert the element at. So initially, it goes without saying, we start with the empty list. We insert 50. So in order to find u equal 50, which is the key, mod 7, which means that it is 7 times 7 equal 48. So it will be, the remainder will be 1. So we insert 50 at location 1. Where do we insert 700? 700 mod 7 is actually 0. So there is no collision. 0 is free. And 76, it will exist at location 6. Then we want to insert 85. 85 mod 7 is actually 1. Is it free? No, it's not free. So we will create a linked list. And this is what we call a chain. This is what we call a chain. This is what we call a chain. It is a linked list. And it is located outside. It is located outside the linked list, outside the hash table. So we will insert it at location 1, but location 1 is not free. So we will create a linked list, and this is the first element in the linked list, which is 85. We want to insert 92. 92 mod 7 is actually 1. So we go to location 1, it's 50, it's not free. We go to the first element inside the linked list, it's not free. We insert another element inside the linked list, which is 92. So how many probes did we do? We tried the first location and we in the linked list, and we insert in the second location, and we insert in the second location. This is called separate chaining. What are the advantages of separate chaining? Simple to implement. We can always add more elements because it's a dynamic allocation for linked list, and it is less sensitive to hash functions, and so we don't really care about memorizing the advantages. The disadvantages, actually, that because you are dynamically creating a linked list, so it might be a little bit slow. What is the major disadvantage? The major disadvantage is that you create a linked list. And when you create a linked list, this means that many elements after inserting your list will be empty because you are creating elements outside the hash table. So this means that there are some that sometimes there is a waste of space for the hash table. Sometimes a waste of space in the hash table. And of course, it uses extra storage. What is the extra storage? Because it stores a linked list. So the total space allocated is the hash table and in memory and the linked list. So this is basically an expensive techniques in terms of memory allocation. So this is basically separate chaining. Once again, separate chaining means you create a linked list. Then let's go to open addressing. Open addressing, the first technique is called linear grouping. The first technique is called linear grouping. The first technique is called linear grouping. Linear grouping. So let's try linear grouping together. Let's try linear grouping together. The
هو الدكتور lost connection ولا أنا البروبلم من عندي؟
لا the doctor lost connection.
do you hear me now يا جماعة?
Yes يا دكتور.
Okay. So I will repeat linear grouping again. So linear grouping, you insert 50, so U equal 50 mod 7. So 50 mod 7 means that u will be equal to 1. I will insert 700. U is equal to 0. This means 700 will be located at position 0. I will insert 76, so it will be located at the 7th element, which is index 6 in the array. Then I will insert 85. So let's tie 85 together. U equal 85 mod 7, which is basically 1. So what does it mean, linear probing? Linear probing means I will apply the collision rule. And what is the collision rule says? It says U plus I mod 7, which is basically the M. Remember, M is the size of the hash table. So, and what's I? I starts with 0 and ends with 6. So I equal 0 till 6. So I will tie U. What's the element of U? 1 plus 0 mod 7. How much 1 plus 0 mod 7? It's 1 mod 7, which is basically 1. Is it free? No, it's not free. So I will try I will loop on the I. So U is equal to 1 plus 1 mod 7, which is basically 2 mod 7, which is basically 2. Is 2 free? Yes, 2 is basically free. So I insert the element at location 2. Then I will insert 92. I will insert 92. So 92, I will try. So I will first evaluate you. 92 mod 7 is basically 1. So basically it's not free. It's a collision. So I will make the collision equation. And the collision equation, U plus I. So U plus 0 is not free because it's basically 1. U plus 1 is basically a collision because it's location 2. Then I will tie U, which is 1, plus 3. So I will insert mod 7. I will insert it. I will insert uh, 1. So 1 plus 0 is 1 mod 7. It's not 3. 1 plus 1. 1 plus 2 is equally 3 mod 7, and I will insert it at location 3. طيب, what if I tried for an element U plus 0, and then U plus, it's not free, U plus 1, it's not free, U plus 2, it's not free, U plus 3 is not free, U plus 4 is not free, U plus 5, U plus 6 is not free. So as I mentioned to you, I goes from 0 till the last element, the last index for the last element inside the hash table. So what if I tried U plus 0 and it's not free? U plus 1, it's not free. U plus 2 is not free. U plus 3 is not free. U plus 4 is not free. U plus 5 is not free. U plus 6 is not free. Then you will declare I cannot insert this element inside this hash table. Okay. So, what is the problem in hashing for you as a student? The problem in hashing for you as a student that when you're doing doing this kind of question is a little bit lengthy. And the problem is that if you just missed one simple equation and you calculate it on, this means that you will be missing large part of the question. So my advice to you, and this was my advice also to the previous section 4, is that you have to make things a little bit slow and a little bit like children. So don't be shy to say equal 1 plus 0 mod 7 equal 1 mod 7 equal 1. Don't be shy to do this, because I really faced this a lot with my students before, and I face it with myself. يعني sometimes when I am solving hashing question بسح unless I am doing it يعني I was very meticulous, then I will commit mistakes. So don't be shy. 1 plus 0 mod 7, 1 plus 1 and then you say 2. So sometimes, lots of times actually, my students will compute 1 plus 1 equal to 3, and then 3 mod 7 it will come to 3. You might be laughing now, but trust me, this happened with me lots of times before, that students are calculating 1 plus 1 is equal to 3, and 2 plus 2 is equal to 5, and everything in that direction. So don't be shy to do this. Okay. So this is the formal technique, and I advise you for linear probing and for any kind of for quadratic probing. Of course, you have to follow the standard way, and for double hashing as well. طيب. Once again, so what is the Baladi way? The Baladi way is that you go for the element. If it is allocated, you go to the next element. If it is allocated, you go to the next element. If it is allocated, you go for the next element. If it is allocated, you go for the next element. If it is allocated, you go for the next element. If it is allocated, you go for the next element. And if the next element, this one with 0, is allocated also, then خلاص, you return to number 1 again, and you will declare I cannot insert in this hash table. Okay. However, if, for example, 2, 3, 4, 5, and 6, they are allocated and 0 is not allocated, you go here, 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 and then you start from the beginning and it's free. So you will not end up here. You have to start from the beginning, and this is the purpose of the mod function. What's linear probing? Linear probing means if you find the element allocated, you go for the next element. And if the next element is allocated, you go till you find if a element, which is the third element or the fourth element or the fifth element or the sixth element or element number 0. Okay. Is it okay for linear probing? Any questions? Should I repeat? Any questions? Linear probing is quite easy. Once again, what is the main problem with linear probing? The main problem is with linear probing that it leads to clustering. What does it mean, clustering? It means that many elements are allocated in certain side of the hash table, and maybe you have a waste of elements in for the other areas inside the hash table. يعني ايه بالعربي؟ انت بتلاقي الارقام كلها متجمعه في indices قريبه من بعض، يعني على سبيل المثال 0 1 and 2، and then ممكن تلاقي indices كتيره فاضيه زي 3 و4 و5 و6. This is what's meant by clustering. What's quadratic probing? Quadratic probing means that instead of having, in this case, u for the collision, u plus I, you have u plus I squared, or u plus I times I. So let's see how to insert using quadratic probing. And this is a very good example, and it is one of the difficult example, definitely. And I will solve 4 or 5 elements, and you will solve the rest, and you will solve the rest, and you will solve the rest. Okay, so assuming that you want to insert 3, 2, 9, 6, 11, 13, 17, 12, and the hash function, which is hash k, equal to k plus 3. U, which is the location, is the hash function mod m, m. What's m? M in this case is 9. 0 is 9 or 10 is 10. So it's basically 0, 1, 2, 3, 4, 5, 6, 7, 8, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 9, which is basically 10 elements. So M is the size of the hash table. M is the size of the hash table. M is the size of the hash table. Let's go together and see how we can insert the element. Once again, hash of k is equal to k plus 3. U is equal to k plus 3 mod m. What is the collision rule? The collision rule is as follows. 2k, if there is a collision, you will do 2k plus 3 plus I times I, which is I square mod m. This is the collision rule. So basically, you first apply u equal 2k plus 3 mod m, and if there is a collision, you apply the collision rule, which is basically, I'm sorry, it wasn't saved properly. So I will apply u plus I square mod m, u plus I square mod m. So let's see how it works. So I will insert 3. So how to insert 3? U equal 2k plus 3, 2 times 3 plus 3 mod m, which is 10, is equal 6 plus 3 mod 10, which is 9 mod 10, which is basically 9. So where will be the element which is basically 3? It will be located at the 9th element, which is the last element. Remember, we start from 0. Let's try 2. 2 times 7 plus 3 sorry 2 times 2 plus 3 mod 10. So it will, so this means 4 plus 3, which is 7, mod 10, which is basically at the 7th location, which is basically at the 7th location. So 2 is actually here. How many probes, how many times did we search for the element? So we have searched for it only one time, only one time. So 9, it will be located at location 1, 0, and 1. 6 will be location 5, 0, 1, 2, 3, 4, 5, 11. Let's see how 11, where 11 will be located. So U is equal to 2 times 11 plus 3 mod 10, which means 22 plus 3, which is 25 mod 10, which is basically 5. Remember, you have to do each and every calculation. I'm just doing this for the sake of time. So, is it location 5 free? No, it's not free. It's a collision. So, if there is a collision, what do? We apply the collision rule. We apply the collision rule. And what the collision rule says? It says U plus I times I mod M. So let's transfer this into numbers. U is equally 5 times 0 times 0 mod M, and M is 10. So it will be 5 also. So this is basically a collision. So we will try 5 plus 1 times 1 mod 10, which is basically 6 mod 10.
Doctor, how do we know which hash function to apply?
No, I am telling you, Yasin. In
Okay.
the question, I am giving you the list of elements to insert and the hash function.
Okay.
So this is part of the question. I will not let you invent the hash function. This is an overkill, actually. Yeah.
Okay, thank you.
Okay. But what you have to memorize, Yasin, you have to memorize one thing. You have to memorize the collision rule. Yes?
Yes, thank you.
Okay. So 5 plus 1 is equally 6. 6 mod 10 is actually 10, is actually 6, in which it is okay. How many times after collision happened did I search till I find the element? Then it's one time, and then I found the element. So the number of probes is actually 2. Then 13. It will be located at location 9, which is actually allocated for key number 3. So after doing the collision rule, it will go to location 0, and I will leave you to do location 13, sorry, key 13, key 7, and key 12. Key 12, you will find that you will apply the collision rules 5 times till you find a free location which will be at 12. Should I continue? Is it clear? Should I continue? Is it clear?
Oh, doctor, I have a question.
Yes.
When we start, like when we do the collision rule for another key, we start again I from 0, right?
Yes, of course.
Okay.
You always start from I equal 0 till I equal m minus 1. So what is the size of this table, ya Abdurrahman?
10.
10. So I will be starting from 0 till m minus 1. Okay?
Okay.
Okay. So this is called quadratic probing. Any questions before I leave? The best thing is to solve this question. You have two challenges when you are solving hash tables question. First, the first challenge is time, and it is time consuming. So you have to, and I give you in the mock exams, I give you two questions, two complex questions actually for hashing, yeah. And so in a normal way, in a normal pace, it might take up to 15 to 20 minutes. And this means that you will تخيش في exam. So because the exam is 2 hours. So if you will spend 15 to 20 minutes in the hash table questions, then you will not find time for other questions. So the best way is to try as much as possible to solve hashing questions in between 7 and 10 minutes. This is the ideal time. And then you will try. You have the mock exams and you have to try as much as possible to improve the time. Second thing is what Freddy has said to the group, that uh, if you lost concentration, يعني سرحت, just for one element, this means that you will lose between 5 to 8 marks just for سرحاية واحدة that you computed U and or later V, سرحاية واحدة, and then everything will be gone out. So be sure that ما تسرحش جامد او ما تسرحش خالص when you are solving hash table question. يعني اياك تسرح، لانك انت لو سرحت مرة، لو حسبت 1 plus 1 equals 3, and trust my word, this happened so many times, yeah. And by the way, it happened with me personally, not 1 plus 1, of course, but it happened with me when I was solving hash questions. Sometimes I just think of something in my work, for example. So just one simple sahaya, then the question is gone. Okay. And by the way, if you find a mistake, then it's very hard to recover it. So so that's why hashing question is a little bit needs concentration. Yeah. Okay. So this is quadratic probing. Last thing is double hashing. Last thing is double hashing. Last thing is double hashing. It seems just I didn't save the last lecture, so I will just do one simple edit. Oh, okay. So double hashing means that I have two functions. I have two functions. And double hashing is really the best way of doing hashing. Why it's the best way? Because you use two hashing functions, which means that if one hashing function مخيشة or it's not doing good, so the other hashing function will be better, and this means that you will allocate uh, as many elements as possible. Okay, so we want to insert the following elements, and then hash 1k equal 2k plus 3. U is 2k plus 3 mod m, so it is the hash function mod m. Hash 2 of k is 3k plus 1, and v equal 3k plus 1 mod m, which is 10. Mod m, which is 10. Again, m is the size of the hash table, which is in this question, it is 10 also. So we will insert 3, and we computed this before. It will exist at location 9. We will insert 2. It will be located at 7. We'll insert 1. It will be located at 1. We will insert 6. It will be located at 5. And then problem happen when we insert 11. Then U will be 5. So if there is a collision, we have to apply the collision rule. We have to apply the collision rule. So now we have to apply the collision rule. So what does the collision rule says? It says the collision rule, U, what's U? U is 2k plus 3 mod m plus V. V is what? 3k plus 1 mod m times I, which is basically from 0 to 9, mod m, which is basically 10. So this is basically the collision rule. Let's first calculate V of 11. V of 11 equal 3 times k, and what's k? It's 11. So 3 times 11 is 33 plus uh, 1, which is 34, mod m, which is 10. So it is 34 mod 10, which is really 4. So now I have V. And I calculated U before, and U is equal to 5. So let us try the equation. 5, which is U, plus 4 times I at the beginning is 0, mod M, which is 10, equal 5. Then 5 plus 4. So is this a collision? Yes, it's a collision because something exists at location 5. 5, which is U, plus 4 times I. Now I is equal to 1, mod 10. And then it is 9. Is 9 free? No, 9 is not free. It is allocated by 3. So this is the second collision. Then I will try 5 plus 4, which is V. Yes.
Where can we see that 9 is not free? I'm just a little bit confused about the format.
Well, Yasin, you have to do this table, okay?
Mhm.
So first thing, you have to have an empty table containing the list of keys, and U is empty, and V is empty, and the probe is empty. Yes?
Yes.
Yes. And then beside this table, you have to draw an empty array, which is a hash table. You want to draw it horizontally, that's fine, but the common practice or the best practice is to make it a vertical table. Yes?
Yes.
And it will be three. It will be free, nothing in it. Yes?
Yes.
This is the second step. The third step, that you will start computing U for the first key, and you will have you will have a space inside your paper where you will do the calculation for every key. Yes?
Yes.
Yes. Then you will calculate U for the key, which is 3.
Is key the same thing as I?
No, key is not I. Key
K.
is
K.
key. Uh, excuse me.
Is it K or is it what we're inserting?
The key is what is we are inserting. So see here, insert the following: 3, 2, 9, 6, 11, 13, 7, 12. 3, 2, 9, 6, 11, 13, 7, 12. Yes.
Yes. Yes.
So key is what we want to insert. Okay. So you will calculate U for the key, which is 3. You will discover that U for the key, which is 3, is located at position 9. So inside the free array, you will go to position number 5 and you will insert the key. So how many elements so far will be at the hash table?
At this position?
Not at this position, inside the hash table in general. One element, because we just calculated one key. Yes?
Yeah.
Yes. Then we will calculate U for key number 2. It will be allocated at position 7. So you update the hash table with 2 at position number 7. Yes?
Yes.
And then you go for 9. You calculate U. And then it will say that you should put key number 9, which is the third element here. You will put it at location number 1. So 0 and 1. So you will update your hash table after the calculation of U. طيب بتحسب U فين؟ احسبها في أي حتة فاضية في الورقة يعني. Okay? Then you will calculate 6. It will go, U will be 5. So you will go at position number 5 and you will insert 6. Okay. And then 11. We are calculating 11. 5 plus 4 times I. I is what, Yasin? Starts from 0 to 9. So 5 plus 4 times 0 mod 10. What's 5? 5 is U. Okay, so after you calculate U, you will discover that this place is not empty. So what is the place that is not empty? It's location number 5. So if the location is not empty, you go and calculate the collision rule. You go and calculate the collision rule. What the collision rule says? The collision rule says that you have to calculate U plus V times I mod M. So 5 plus 5 is U. First you will calculate V. V of 11 equal what? Equal 3 times 11 plus 1 mod 10. So V is actually equal to 4. U is equal to 5 and V is equal to 4. So what does the equation says? The equation says U plus V times I mod M. So U is 5 plus 4 is V times I. I at the beginning is equal to 0. Mod M is 10. So 5 plus 4 times 0 is 0, so 5 plus 0 is 5, mod 10 is 5. The fifth element, is it allocated? Yes, it is allocated, so it's a collision. Then I will continue. U is equal to 5 plus 4v times I. I is 1. 5 plus 4 times 1, 5 plus 4, mod 10 is equal to 9. The ninth element contains key number 3. So this is the hash table so far. Then it's allocated. 5 plus 4 times 2. So 5 plus,
After we do the U and V calculations, we do the collision check.
you do the collision check. And you change basically I. You change basically I. So 5 plus 4 times 0 mod 10. 5 plus 4 times 1 mod 10. 5 plus 4 times 2. 5 plus 8 is 13. Uh, 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 sorry, 5 plus 4 times 2 is 13. And this is basically where you will insert the element, which is 11. Where will you insert it? You will insert it at position 3 in the hash table. 0, 1, 2, 3. How many times did you check till you find the element? This is collision. This is the first trial. This is the second trial. And then you find a free place. So you will make 3 probes till you reach the free place. So this is basically how to calculate the collision.
Okay.
Then, is it okay, Yasin and everyone?
Yes, it's good.
Everyone, is it clear? My friends, is it clear?
Yes, doctors.
Anyone have, so as I said in the group, it is constant, you have to know arrays and you have to know the multiplication table. And you have to be concentrating. One number will screw up anything and everything. Okay, then I will leave you to calculate 13, 7, and 12. However, if you will calculate 13, so you will go and calculate U. It will go at position 9, which is not free. So you will calculate V. V will be 0. And you will start making the collision rule. So you will start with U. U in this case, it's 9. U in this case, it's 9. And V is 0. So 9 plus 0 times 0 mod 10 is actually 9 mod 10, which is 9. So a collision. Then 0 times 1, V is 0. So 0 times I, which is 1. So it is basically 9 also. So 5 plus 0, which is 5, 9 plus 0 times 1 mod 10, which is 9. 9 plus 0 mod times 2, it will be mod 10, it will be 9, which is a collision. You will keep 9 plus 0 times 3. It were mod 10, it's also 9, which is the collision. Because V is 0, so anything multiplied by 0 is obviously 0. So you will continue from I equal 0, I equal 1, I equal 2, I equal 3, I equal 4, I equal 5, I equal 6, I equal 7, I equal 8, I equal 9. it will be a collision, 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 and then you will discover that you cannot insert the element 13. So you will write to me in the exam paper, I cannot insert 13. So this is basically for 13. For 7, it's straightforward. You will find it. For 7, you will be also facing the situation where you cannot insert 7. And then when you calculate 2, you will find it after 2 trials. So sometimes you might be finding yourself not able to store the element after I has been iterating from 0 to 1, 2, 3, 4, 5, 6, 8, 9. If the size of the table is 6, so 0, 1, 2, 3, 5, 6. If the size of the table is 3, then you will be iterating 0, 1, 2, etc. So I will repeat how the question comes. Usually in the question, I will give you the hash function, which is 2k plus 3, 5k plus 1, and I will give you the elements that you want or the keys that you want to be inserting, and what you have to memorize is the collision rule. So I will tell you, please calculate, please show me the hash table in case of linear probing, in case of quadratic probing, in case of double hashing, in case of double hashing. So what you have to do, first you have to construct this table, and you will write those keys, which are the elements that you want to insert. Then you will start calculating U. If the place is free, that's fine. You will insert it in a hash table. If the place is not free, then you have to apply the collision rule. The collision rule says U plus I mod M if it is a linear probing, U plus I times I mod M in case of quadratic probing, U plus V times I mod M in case of double hashing. V, in case I give you a double hashing question, so I give you U and V. And you have to memorize U plus V times I mod M. So basically, you construct a table. You put a table like this in case of double hashing. You put the key, you put U, you put V, you put the probe. Those things are initially empty. I'm sorry. Those things are initially empty. You put the keys I gave you in the question, which is this part, and you have the hash table as empty. You calculate U, and if the place is empty, so you put it inside the hash table. If it is not empty, you start first calculation for V, and then you apply the collision rule. U, which you have already calculated, plus V, which is basically the other hash function, times I. I will range from 0 till M minus 1. M is the size of the hash table. You will calculate U plus V times I mod M. And then if there is a collision again, you will calculate U plus V times I. So the first iteration, I is equal to 0. The second, I is equal to 1. The third is I is equal to 3, to 2, 3, 4, 5, 6, 7, 8, 9. So if the last index is 9 and all of them are collisions, then you declare that you cannot insert the element. So what you have to do when you are studying this is to solve the mock-up exam questions and to try your best to have in this question between 7 and 10 minutes. Other than this, you will be eating up from the other exam question and you will not be finishing in the time. So fortunately, this is the last slide in the syllabus. Thank you very much for joining the course. We will be, inshallah, starting the review sessions, starting the QT session, starting anything and everything that we can do for the remaining part. Thank you very much and have a blessed night and see you inshallah within the spring break. Thank you very much.
Thank you, doctor.
Doctor.
Have a good day.
Thank you, doctor.
أنا عندي سؤال بس.
Mm.
الميد ترم جاي من أول التوبكس من 7 ل 14 صح؟ اللي هو من أول اللينك ليست.
لا أنا بكرة إن شاء الله هبعت لكم التوبكس بتاعت الميد ترم، يعني هيبقى أكتر من كده يعني.
هيبقى أكتر من كده؟
هيبقى في حتة بس من ميد ترم 1 يعني، حتة مش كبيرة يعني، بس في حتة من ميد ترم 1 يعني.
طب هو هيكون الساعة كام طيب؟ لأن أنا عندي الميد ترم في نفس اليوم
أكيد قبله يعني، هنتفق يعني. This is not going to be a problem.
تمام. حاجة أخيرة، الريفيو لو حلتها وكان تمام this is enough ولا؟
بس تعرف تحلها، مش قصدي انت يعني، بس يعني اي حد يعني يعرف يحل ريفيو، بس لازم يستدي عشان يحل ريفيو يعني. مش هتقدر تحل ريفيو كده عامة يعني.
تمام.
يعني لازم تستدي كويس يعني. it's not an easy review question يعني.
والميد ترم يكون في نفس الصعوبة ولا ده بس
آه نعم.
الميد ترم
آه
هيجي في نفس الليفل ولا ده بس براكتس بس؟
الميد ترم هيجي نفس الصعوبة أو أصعب شوية.
تمام. ثانك يو دكتور.
بس يعني تقريبا نفس الصعوبة يعني. لا يعني هو مش هو أصعب من ميد ترم 1 تحت أي ظروف يعني.
تمام. ثانك يو دكتور.